we have decent knowledge of SOP and POS forms. In this presentation, I will solve 3 examples and also explain few tricks so that you can solve questions directly in your exam. We will start with example number 1. In a minimal SOP form, number of minterms in the logical expression A or B complement and C are. So we have a logical expression, let's say it is for function f and it is equal to A or B complement and C. This is the representation that we call as the minimal SOP form. So we have the minimal SOP form. We want the canonical or standard SOP form so that we may have the number of minterms. We have to count the number of minterms when we have the canonical SOP form. So first thing that we have to do in this problem is to find out the canonical SOP form from this minimal SOP form, and then we have to count the number of minterms, and that will be our answer. So let's start with it. We have to follow the same steps that we discussed in the last presentation. The step number 1 is to find out the number of variables and also what are their names. And I can see there are 3 variables A, B, C. So let me write it down. We have 3 variables and they are A, B and C, right? And step number 2, we have to find out the absent variables. So this is, let's say, term number 1, this is term number 2. In term number 1, you can see we have A, we don't have B, it is absent, and we don't have C. In the same way, we will check for term number 2. In this, we don't have A, but we have B in complemented form. We have to only find out the variables present or absent. You don't have to worry about this complement. And we also have C. So in term number 1, we don't have B and C, whereas in term number 2, we don't have A. And in step number 3, we will AND 1, and we will AND these ones number of times the variables are absent. We don't have B, so this 1 is for B. We don't have C, so this 1 is for C. I have already explained these things, why we are ANDing 1 with the present variables in the last presentation. And for this term, we have B and C, but we don't have A, so we will AND 1 for this A. Now I can write this 1 as B or B complement, this one as C or C complement, and in this term we already have B complement and C, and we will write this one as A or A complement. Now we only have to open these brackets by using the distributive law, and we will do it quickly. A and B or A and B complement, and C or C complement is there. From this we have A B complement C or A complement B complement C. And now we will open these 2 brackets. We have A B C, A B C complement, A B complement C or A B complement C complement, and these 2 terms will come as it is, A B complement C or A complement B complement C. Now we have to find out if the main terms are repeated. A B C is not repeated, A B C complement is also not repeated, A B complement C is repeated. You can see it is repeated. A B complement C complement is not repeated. A complement B complement C is also not repeated. So we will eliminate this A B complement C. There is no need to write it 2 times because you already know A or A is equal to A. So we are using this property of Boolean algebra, and finally we will have our canonical form as A B C or A B C complement or A B complement C or A B complement C complement, and finally A complement B complement C. So how many minterms are there? 1, 2, 3, 4, 5. So we have 5 minterms in the canonical form, and answer is option number C. So So we have solved this example number 1, and now we will move to example number 2, and it says with two variables, maximum possible min terms and max terms are. So we have two variables, let's say a, b are the two variables, and we have to find out the maximum number of min terms and maximum number of max terms when we have two variables as a, b, or any other variable that you want to take. So how to approach for this problem? You already know when we have two variables, we have four possible combinations: a complement, b complement, a complement b, a b complement, a b. These are the four possible combinations, and we write min terms. We write min terms when the output is high, and we write max terms when the output is low. This is something you already know, and if all the possibilities for these two variables, when a is 0, b is 0, a is 0, b is 1, a is 1, b is 0, and both of them are 1, and for all these four cases, if we have output equal to 1, this is possible, right? Then we have four min terms, and if all the outputs are low, then we have four max terms, and in question we have to find out maximum possible. So definitely it is possible to have four min terms and four max terms for two variables. So we can generalize it. If we have n variables, then we have 2 to the power n min terms or max terms. So this is something that you have to keep in your mind. The maximum possible min terms and the maximum possible max terms are 2 to the power n. For three variables, we have 8 min terms, the maximum possible min terms, and 8 max terms as well. So in question there are two variables, so simply we have 4 as the maximum value of min terms and the max terms. So option B is correct, and we are done with the example number 2 as well. And the last example is very important. This one is very important. For n equals to 4, n is the number of variables. So we have four variables. What is the total number of logical expression? First we will find out for n equals to 2, then we will generalize the case and we will find out for n equals to 4. So let's start with it. For n equals to 2, when we have two variables, and let's say the variables are a, b. So the first thing that we can have is 1, right? The second thing is 0. Then we can have a complement. When both a and b are 1, it means we have 1 or 1 is 1 and 1 is 1. When both a and b are 0, then also we have 0, and we can have b as 0 and a as a. So we have a as a complement, b as 0, so we have a complement. And in the same way we have a b complement, a complement b, a b, and you cannot write b a as an independent case because a b is equal to b a. This is the mistake most of the students do in this type of problems. The next thing is a or b, and again b or a is same as a or b. Then we have a complement b or a b complement, and a b or a complement b complement. You can also have b or b complement, a or b complement, a complement or b, a complement, b complement, a complement or b complement. So these are the possible logic expressions that we have from the two variables, and let's see the number of logic expressions that we have. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 and 16. So in total we have 16 logical expressions for two variables. Let's generalize it. 16 for two variables, so I can write it as 2 to the power 4 2 to the power 4 is 16, and we have two variables, so I can write this 2 is representing the variable. So if we have n variables, then the total number, this is only a single m, number, the total number of logical expression is 2 to the power 2 to the power n. So this is a very important thing that you should remember. It is very important, and you can directly find out the number of logical expressions when you have the variables as 4, 5, 6, because you cannot write all these possibilities. We can do it for two variables easily, but when the variable increases, it is very difficult to write all the possible logical expressions. So you can remember this formula 2 to n, where n is the number of variables, and you can have your answer. For n equals to 4, let's see what we have. We have 2 to the power 2 to the power 4. So 2 to the power 4 is 16. So we have 2 to the power 16. I will use my calculator for this purpose. 2 to the power 4 is 16, and we want 2 to the power 16. So 2 to the power 16, it gives 65536. So it is equal to 65536, and this is the answer. Now you can see it is nearly impossible to write down 65,536 logical expressions for 4 variables. So you can remember this formula and directly have your answer. This is all for this presentation. If you have any doubt regarding any part of this lecture, you can ask in the comment section. And this is the last lecture on SOP and POS form. From the next presentation, we will start a new topic. So see you in the next one.